IMS Gate Academy. I hope you have enjoyed our theory of machine gate booster session yesterday. In the last session, we have covered simple mechanism, gear train, flywheel. These are the topics that we have discussed. Okay. Now, in this particular session, we are going to discuss the vibration, the most important topic of entire theory of machine subject for mechanical engineers, right? And we will see some of the questions, okay, from the gyroscope as well, right? So, everyone, please share the session with your friends. Wherever groups you are joined, in that you can share this session for those people who are preparing for the gate examination. Because in the last few days, we can say last 50 days almost, you have to be focused on the numerical practice more, okay? First source of numerical practice is PYQ, second is the quality problems that we are giving in the gate booster session. So that your confidence basically boosts from solving such questions, your confidence level definitely will increase. And see, the point is you will get the confidence, and with that confidence you will be able to solve all the questions in the gate examination as well, right? So we'll be solving the question, okay? First I will give you the question and then we'll solve it. While doing the solution, I will explain you the concept in detail, so that even if you have missed or you have not understood the concept earlier, you can also understand right now in this particular session. So it will be very helpful for those students who are preparing for GATE 24 examination, right? So we'll start with the session, guys. So some small important information, right, regarding the Telegram channel of IMS Gate Academy. You can join this Telegram channel so that you will have all the informations of the recent schedules that we are having for free YouTube lectures, webinar information you will be getting, and all the latest information of the job recruitment notifications, everything you will be getting there. And one more thing, quizzes you will be getting there, right? So that channel is a very useful source of information for all the GATE aspirants. So you can kindly join this Telegram group. The link is also provided in the description, okay? With that link you can join the group. Now, next thing is regarding the live program that IMS Gate Academy is offering. Now, if I talk about the top features of the live online program, it has more than 800 hours of live content, okay? Live classes are there, more than 800 hours. Apart from that, what you will be getting? You will get physical books, theory books you will be getting, exercise book you will be getting, and a PYQ book. Now, if I talk about the exercise book specifically, it will have a questions based on the difficulty level, like level 1, level 2, level 3. So you will have a sufficient source of practice sets, okay? So in such a way that you don't need to look for any reference textbooks. All the practice problems are given in the practice book. So you don't need to look for any other material. If you have this exercise book, then it is more than sufficient for your GATE preparation, right? Apart from that, you will have a one-to-one personalized mentorship sessions that IMS Gate Academy unique feature that we are providing. So basically with this mentorship session, in your GATE preparation, you will be always in touch with your faculty or the mentors, right? Because GATE preparation is a long journey, and some of the times we are facing lot of challenges and difficulties. So you can directly connect with the faculty with one-to-one mentorship sessions. And in this sessions, faculty will help you out in all of the problems or the challenge that you have faced in your preparation, okay? So faculty will give the best possible solution for your problems, right? So this is one-to-one, okay? So you can discuss your personal doubts also. Everything you can discuss with the faculty. Faculty will be always available for your help. Apart from that, online test series, which is again a very important tool for the preparation of the GATE examination. Once you have prepared the content, okay, you have prepared the syllabus, second thing is what the practice, and from where you will practice the test series. So practice also is what very important here. Mock test series are designed in such a way that it will actually resemble with the actual GATE examination. So if you attempt the mock test, okay, at least 10 mock tests you should attempt, so that your confidence level will increase and you will understand what kind of paper you will be having in the GATE examination. Because we have to be habitual in those test series, 3 hours complete mock test I'm talking about. And if you want to take an admission in IMS Gate Academy, these are the numbers that we are having here, okay? And it is also mentioned in the description box. Or if you have any of the doubt or any query you are having regarding GATE programs that IMS Gate Academy is offering, you can book a free counseling session. It is a free counseling session you can book, and you can discuss whatever doubts or queries you are having regarding the GATE preparation, right? So you can call also, and you can book your free counseling sessions as well. Okay, now everyone will discuss our theory of machine session number 2. Okay, and we'll start with the vibration. As I told you, vibration is one of the most important topic, and here it is our first question. Here it is our first question. Clear? Okay, start solving everyone. This question belongs from the chapter vibration, right? So hardly it will take 2 minutes. It's a very important question, guys. Everyone should attempt this one. Got it? Everyone should attempt this question. Do it fast, everyone. Vibration. So in the starting, more numericals we will be discussing from vibration, because the weightage of vibration in entire theory of machine is highest. Okay, always 2 to 3 questions you will see from the vibration chapter itself, right? So we have to solve all variety of problems. Okay, that is very important here. So these are the new variety of questions that you need to practice. Like in this particular problem, what they have given, a vibrating system, a coil spring stiffness is 50 Newton per mm. Okay, just focus on the units as well. Most of the time we are doing mistakes in the units only. Unit they have mentioned is 50 Newton per mm. Supports a vibrating mass of 250 kg. Okay, this is another information at the free end. In addition, the motion of mass is controlled by a dashpot whose resistance is proportional to velocity. Okay. Now, from measurement, it is found that the amplitude at the beginning of the fourth cycle, is 0.8 times the amplitude of the third cycle. Okay. So this is the information they have given. Stiffness they have given the mass, and they have given the ratio of the displacement. Displacement, which displacement they have given? Beginning of the fourth cycle is equals to 0.8 times of the amplitude of third cycle. That is what the information given. And what they are asking, damping coefficient. They are asking the damping coefficient of the dashpot and the damping factor as well. Now, so the very first thing that we will do here is writing the given parameters. 50 Newton per mm. And you should know the standard unit of stiffness is Newton per meter. Okay. Now, the mass they have given is 250 kg. Correct. And other than that, they have given this ratio. X4 is 0.8 times of X3. This is the another information. Right. So these are the given parameters we are having. Now, we have to understand with this given parameters how we will be able to calculate the first part, the damping coefficient and the damping factor. Just think about the relations. Okay, everyone. Just think about the relation which will help us to calculate this, both the options, like damping factor and damping coefficient. So just everyone try. Okay, these are the given parameters. Think about the relation which can relate this given parameters with this unknowns. Okay, many people's like students are asking how to start a problem. Simple thing, given parameters we have written, unknown it is mentioned in the question. Think about the relation which will connect both this given and unknowns. Which relation, which formula is going to connect the unknown with the given parameters. Think about that parameter. Okay, everyone please try and tell me your answers in the chat box. Whenever amplitude they have given, okay, whenever they have given the amplitude, what we can do it here, see, I hope you remember the logarithmic decrement formula, xn by xn plus 1, right? So your del equals to ln xn divided by xn plus 1. So basically x3 by x4, so ln 1 by 0.8. So we will be getting logarithmic decrement, but that's what not they are asking. Logarithmic decrement they are not asking. So why I have calculated first logarithmic decrement? Because logarithmic decrement can also be calculated by using this relation, using damping factor. This is the another formula of logarithmic decrement using damping factor. Now once I have calculated the logarithmic decrement, I will use this relation for the logarithmic decrement. I will be able to calculate what? The damping factor, damping ratio basically. So I will equate with this damping factor formula, second formula, logarithmic decrement formula basically, right? So this is what, very simple. Now you will be able to calculate the damping factor, this one, which is what they are asking in the second option, right? And damping coefficient is what? C divided by Cc, and Cc we know that critical damping coefficient, which is written as 2 into root k into m. So if I have to find out the damping coefficient, it will be equals to Cc times damping factor or damping ratio. Cc value is 2 root k into m multiplied by damping factor, right? So this relation we need to use in order to calculate damping coefficient of damping here. Okay, damping coefficient, that is what they are asking, option number 1. But first I have calculated the logarithmic decrement equated with this logarithmic decrement value equated with another formula of logarithmic decrement, which is 2 pi damping factor under root 1 minus damping factor square. From that I will be getting damping factor value. Is that clear, everyone? Yes or no? Is that clear? So now you will be getting the answer of damping factor here. Now everyone do it the calculation fast. And I know many people usually do mistake in the calculation part here, basically at this point of time, this equation. I will tell you like how usually people will do mistake here. Okay, so ln 1 by 0.8 equals to under root 1 minus psi square, like this. Okay, so some value will be having. Okay, so after that what you can do, you can take the squaring on both the sides, because this is under root. Okay, it is an under root, so you can do the squaring on both the sides and you can easily get the answer of damping factor here. So everyone please do the calculation and tell me your answers for the damping factor. Tell me your answer for the damping factor. Everyone please calculate. Okay, just mention your answer in the chat box. So this value, okay, just I will mention some of the answers here. (0.2231). This ln 1 by 0.8 value. So I've already solved 0.2231. This is the answer for this value, equated with 2 pi damping factor under root 1 minus damping factor square. So taking the square, so 0.2231 1 minus damping square equals to 2 pi whole square into psi square. Okay, now from this equation you can easily get the answer of damping factor. So anyone got the answer? Whether anyone got the answer, yes or no? Damping factor answer, what will be the answer of damping factor? So now after this, no, like question becomes very easy. Only struggle that you will face initially is what? To identify which relation, which formula I need to use. That is what the initial struggle. Initial struggle in all the problems is what? The first step. What is the first step that I need to take? Are you able to understand? The first step that we need to take. So how to identify what will be our first step? It will be totally decided by the relation which connects your given parameter, at least one of the given parameters, with the unknown. So displacement value connects the logarithmic decrement, and logarithmic decrement actually connects with the damping factor. Okay, So damping factor, basically they are asking, amplitude ratio we know. So that's how we got the relationship between given and unknown. Okay, so that's how we'll get the answer here. So finally answer for this one is 0.035. Approximately it will be there, 0.03548. Yes, this is the answer for damping factor. Yes, Rahul Kumar, you are getting 0.78. No, just cross check your calculations, Rahul. 0.03548 will be the damping factor answer. Using this damping factor, we can also calculate our damping coefficient. Stiffness is given in the question. Stiffness given is 50 Newton per mm, but which will be now 10 to the power 3 into mass. What is the mass given? 250 kg. From here you will get the damping coefficient as well. Okay, I hope like relations are clear, why we are using such relations. Okay, what is the approach that we have taken here? I hope everything is clear. Yes or no? Just tell me. So this is the one answer. Another answer we will be getting from this equation. So please cross check your calculations. Calculation is the most important thing and we usually but neglect. We will not do anything for calculations. We will not put any effort. Okay, so you have to be very careful regarding your calculations part. Okay, so do the calculation and tell me this damping factor, damping coefficient answer. Rahul, just tell me your answer for damping coefficient. What will be your answer? Oh, see, logarithmic decrement is what? ln xn by xn plus 1. This is what the ratio. So ln 1 by 0.8 it should be there, not 0.8. 1 divided by 0.8, because xn divided by xn plus 1 will be what? x3. Okay, x3 divided by x4, which will be equals to 1 by 0.8. Right? So that's what we usually, small mistakes we have done. So it if you have writing ln 0.8, you will get wrong answer. It should be ln 1 by 0.8. Okay, so finally damping coefficient. So ln nahi liya aapne, so okay, so that small mistake, but again be careful these things. 250.88, 250 approximately will get the answer 0.88 Newton second per meter. This is the answer of damping coefficient. I hope now it is clear, everyone. These are the answers. Done? Okay. We'll move to the next problem. We'll move to the next problem, guys. This one. Again, this is very important problem. Natural frequency calculation part. Natural frequency calculation part. Okay. If you see in the previous year, most of the questions they have asked from this topic also. And usually in this problem, many students will face difficulty. Why? Because there is no direct formula here. Here, one approach we have to use. In that approach, which relation, which concept we are using? Newton's second law. Newton's second law we are taking, right? Or you can say D'Alembert principle as well. In which what we will do, body under equilibrium condition is there. We will provide some disturbance to it. We will provide some disturbance to it. Okay, once we have provided disturbance, then we will release it and then we will observe the vibration. That's how the vibration will set up in the body. Okay, once we have displaced it, we will see the forces that is coming here. Very good evening, Saurabh. Okay. So, understand the approach of natural frequency, everyone. In natural frequency calculations, what we will do, because as there is no direct formula, we have to follow the approach. Approach is what? Body under static equilibrium, we have to disturb it. So once we have provided disturbance, then we will see the effect of forces, how the forces is creating moments or the torque. Okay, that's all analysis we have to do. Right, then we can apply directly Newton's second law or D'Alembert principle as well. Right. So in this problem, we will understand the approach, and if you have understood the approach, no matter whatever mechanism, whatever system they have given, you can calculate all the cases. In all the cases, you can easily calculate the natural frequency. Okay, no matter what type of system is they have given. So you don't need to worry about, you need to focus on the process, what step we need to take. Okay, now I will explain here, everyone. So this is a system we are having, and this is the hinge point. Now first of all, one axis I will draw here. See, initially this is what axis we are having. Now if I provide the disturbance in anti-clockwise sense, let's suppose I provided the disturbance, I have provided disturbance like this. Theta is my disturbance I have provided. So what will happen? This particular semicircle shaped body will little bit rotate towards in anti-clockwise sense. Basically, it will rotate. Okay. So what happens actually? What major change you will see here? The center of gravity is going to what? Change here. Initially, center of gravity will be, see, initially at this point of time, center of gravity will be somewhere here, and the distance of center of gravity from this diameter will be 4r by 3 pi. Yes or no? Simple. But now actually what happens? The center of gravity is going to change. Okay, the center of gravity is going to what? Change. Once I have given this disturbance theta, how it will change? See, it is going to be changed like this. Okay, like this it will change. So initially center of gravity was like this, now it is like this. So when it is like this, so from here the weight mg is going to what? Act. Now mg will have some moment value about the hinge. Yes or no? Initially it is not having. Why it is not having? Because mg line of action is passing through the hinge point. Initially mg line of action is passing through the hinge point. So there is no point of taking the moment. Moment value will be 0. Now secondly, mg value about the hinge will have now some moment because of the disturbance we have provided. Now see, theta disturbance provided, opposite to that we will have inertia torque that is coming here. Always opposite to the displacement, inertia torque will be coming. Now one more torque or the moment value will be there because of mg, and mg multiplied by this distance. That distance will be nothing but 4r 3 pi multiplied by theta. Right. So this is what the theta value we are having. This is the theta value. So this theta turn we have told, na, this much angle it has turned. Four r by 3 pi. Now, what we need to do, as per D'Alembert principle, we need to add all the forces, if forces are there, or all the moments values and equate with 0. So when we are adding all the moments, we have to consider inertia moment or inertia torque as well. Right. Now see, inertia torque I theta double dot plus the torque because of this mg weight, mg into 4r by 3 pi into theta. Now, what is mass moment of inertia? Mass moment of inertia about the hinge point. So what is the mass moment of inertia we will write here? Tell me everyone, what is the mass moment of inertia value? What will be the mass moment of inertia value? See, simple thing. We have this semicircle. This is a complete disk, right? About this center, if I calculate mr square by 2 is there, right? mr square by 2. Done. Now for this hinge, what is the mass moment of inertia? What kind of change you will expect? Tell me. And remember this point, everyone. The center of gravity is here, distance 4r by 3 pi, right? But about which point we need to calculate the mass moment of inertia? About the hinge point, which is on the diameter. Okay, this is the semicircular body. About this point we need to calculate the mass moment of inertia. Okay, about this point basically. So what will be the answer of mr square by 2? What will be the mass moment of inertia value? Rahul, you are telling option A. You're getting option A. Okay, we will see which option is correct, but tell me the formula, the mass moment of inertia value. Which mass moment of inertia value you will be taking here? Pi r to the power 4. Why r to the power 4 it is? It is mass moment of inertia. Okay. Because about the center point it is, about the diameter it is having the hinge. Okay. Hinge is not at this point. Hinge is at this point. So simply mr square by 2 into theta double dot plus mg into 4r divided by 3 pi into theta equals to 0. And now we will write this equation in the standard form, theta double dot mg into 4r divided by 3 pi. Okay, and this mr square by 2, here it will be coming mr square by 2. 2 will go to the numerator side. Okay, and here the theta value equals to 0. Now just simplify this thing. M will get cancelled out. Okay, and this r will get cancelled out with this one. So theta double dot will be having as 2 4 into 8 8g divided by 3 pi r, okay, into theta equals to 0. So here we will get the answer of omega n as under root 8g divided by 3 pi r radian per second. This is what the answer we will be getting here. Clear, everyone? This is the answer we are having. Correct? Rahul, is it clear? Tell me, is it clear? So option, if you see, under root 8g by 3 pi r. So option D is the correct answer here. Option D is the correct answer. Just please confirm, is it clear? Yes or no? No, Rahul, understand, mass moment of inertia we have to calculate. That's why you have written previously the area moment of inertia. Mass moment of inertia we have to take whenever we are talking about the rotations. See, understand, the application of mass moment of inertia, where it is coming, in the case of rotation. In the case of bending, you will see area moment of inertia. Understand the application. Area moment of inertia you will see generally in the case of bending. But in case of rotation, mass moment of inertia you will see. Okay, got it? Now coming to the next problem. Next, again, vibration. Most of the problems we are solving here from the vibration chapter, because as it is having more weightage, compared to other topics, that's why we have to give more importance to the vibration, right? Now attempt this problem, everyone. Attempt this problem again from the vibration topic. See, machine mass is 100 kg supported on a springs which deflects 8 mm under the static load. Now, we will write down all the information here, and while noting down the important information, you should not do mistake also. Okay. Machine mass already they have given 100 kg. Okay. On supported on springs, right now only springs they are talking about, and which deflects 8 mm under static load. So this is the mass deflection they have given 8 mm. Okay, under the static load. So because of this information, we can calculate the stiffness, right? Because you should know that load equals to stiffness multiplied by the deflection here, and we have to calculate the stiffness. Your load, what is the load? 100 multiplied by 9.81, okay, divided by the deflection, that is 8 mm, 10 to the power minus 3. So from here the stiffness value you will be getting. So usually this information is given in the question to calculate the stiffness, which will be used later in the numerical. Mass is given, so static load will be the weight of the body, 100 into G, 9.81, divided by the deflection, 8 into 10 to the power minus 3, because it is mentioned in mm. So from here you will get the stiffness. Got it? Okay. After that, with negligible damping basically means they are talking about damping is not provided. The machine vibrates with an amplitude of 5 mm. Okay, we'll write it like this. Amplitude they have given as 5 mm. So at this point of time, damping is not given. So damping coefficient value 0. Damping factor value 0. So this is what we need to understand. From this single word, negligible damping, damping coefficient 0, damping factor or damping ratio is what? 0. That is what we have concluded just by reading the question. Okay. 5 mm they have mentioned. Subjected to a vertical harmonic force at 80% of the resonant frequency. Okay. Omega equals to 0.8 of omega n they have mentioned. Clear? So this is another set of data they have given, right? Now when damper is fitted, into the system and resonant they have mentioned, it is found that the resonant amplitude is 2m. Now what does it mean, resonant amplitude? It means they are talking about that amplitude when the resonance condition is there. They are talking about the amplitude when the resonance condition is there, and resonance condition basically means omega equals to omega n. So that is a separate case. Then they are asking the damping ratio. Okay. Now then you will be telling, okay, you will say, sir, why this information is given? What is the purpose of this information? Now we have write down this information. From this information we will get the stiffness. What actually we will be getting from this information? Understand, very important point. So I hope you know the formula here. Amplitude of vibration. Some people will write A, some people will write X, so that is not an important point here. Amplitude equals to F naught by K divided by under root 1 minus R square whole square plus 2 psi into R whole square. Now F naught by K, some people will write it like this also. This is static deflection, okay, or the deflection because of the F naught force. So that is not given in the question, right? F naught is not given. F naught is not given in the question. Generally, how they will give F naught? They will give some harmonic force as F naught sine omega t, like 50 sine 50 t, 50 sine 10 t, like that they will be giving. So from that we can understand what is F naught, but that information is not given in the question. So basically we will write it X static as well, as it is we will be writing. Okay. Now, so this is there, this information is given. Now we will use all this information. X value 5 mm. 5 mm means 5 into 10 to the power minus 3, and this X static will keep it as it is. Right. Now under root 1 minus R square. What is 1 minus R square? What is the value of R? You can understand the value of R here, 0.8. Okay. What about this psi value? Already it is mentioned negligible damping, so it has a 0 value. A 0 will be there, so 1 minus R square, 1 minus R square whole square, it is here. Now we'll simplify now further. Now we will simplify this equation now. See, 5 into 10 to the power minus 3 equals to x static. Here we will be having 1 minus R square. So your x static value 5 into 10 to the power minus 3 multiplied by 1 minus R square. R value is what? 0.8 square. Like this you will get the answer. So your x static value you will be getting from here. And this value will be using in the next case. Next case they have given information, damper is fitted and found that resonant amplitude is 2 mm. Now what information they have given? Next information, this x value they have given is 2 mm, but when omega equals to omega n, that is R value equals to 1, which means your x divided by x static equals to, when R equals to 1, what formula will change? How the formula is going to change? 1 minus R square, 1 minus 1 is 0. So only 2 into psi will be there. 1 by 2 psi. So from here you can easily get the answer. Okay. So x value already 2 mm, 2 into 10 to the power minus 3. X static you will be getting from here, and you will put in this equation and you will get the answer of damping factor as well. Correct everyone? What is the value of x static? I hope everyone calculated. So tell me your answer. X static value. So approximately, okay, if you see, it is coming around 1.8 into 10 to the power minus 3. Okay, 1.8 into 10 to the power minus 3, it is the value of x static. That value you will be putting here. So from here you will get the damping factor. Very easily you will get the damping factor. So understand, sometimes no, they will give 2-3 cases. With the help of case 1, some unknown parameter we will calculate. That unknown parameter will get utilized in case 2, and from that we can finally get the answer of unknown that actually they are asking. Got the idea how to approach such problems? First, this ratio you should remember. Okay. Generally, if not by K, sometimes we will write, or sometimes x static directly we are writing. Done? Is it clear? Yes or no? This question, everyone, is it clear? So finally calculate also the damping factor. So if you see, approximately 0.45 is the answer. Yes, resonance condition basically means omega equals to omega n, which means R value is 1. Correct, absolutely. Absolutely correct. No, Rahul, you are confused with the resonance and the critical damping. Critical damping means the damping factor is 1. Don't confuse with both the things. See, resonance condition means omega equals to omega n. But when you say critical damping, it means damping factor is 1. Both are separate conditions. Okay, both are separate cases. Don't mix like resonance condition is there, so critical damping is there. No, it's not like that. 0.5 answer is correct. Your answer 0.5 is absolutely correct. But don't confuse with this conditions. Both are separate things. Don't mix. Clear? Now, in this particular problem, calculate one more thing, damping coefficient. Calculate the damping coefficient also. Okay, calculate the damping coefficient. Actually, in this question, damping ratio they are asking, but calculate the damping coefficient as well. Calculate the damping coefficient as well. Okay, how you will get the answer of damping coefficient? So damping factor is damping coefficient divided by critical damping. So critical damping equals to 2 into root over k into m. Right, like in previous cases how we have done. So this damping factor multiplied by Cc, which is 2 into root over k into m, like this. Got it? So please calculate the damping coefficient as well. Do the calculation, everyone. Damping coefficient as well you should calculate. And tell me what answer you are getting here. Stiffness, I hope you remember how we have calculated, like this. Using this information we have calculated the stiffness. Because sometimes no, they will not directly give the stiffness. They will say, okay, this is the body and this much is the weight it is having. So as it is connected with the spring, this much reflection we are getting. So simply stiffness equals to load divided by the deflection. Okay, directly you will be getting the stiffness. But remember, in all the formulas wherever stiffness is there, we will be writing always in terms of Newton per meter. We will be always be writing in terms of Newton per meter. That is a standard unit. Okay, and obviously in the question they will give Newton per mm, Newton per centimeter, like that they will give. So at that point of time you should immediately understand we have to change the unit. Okay, we have to change the unit here. Got it? Now please calculate this damping coefficient finally. Last part, everyone. Any answers for this damping coefficient? Damping factor 0.45 you told correct, but damping coefficient answer you should tell finally. See, more and more questions you will solve, slowly you will get the confidence, you will understand the concepts. So once we are reading the concept, we are just discussing the theoretical part of the concepts. No, we assume that we are getting the concept, but only while solving. See what happens. No, if you are not solving the question, you will always think like you know the concept because you have read the class notes or the theoretical things you know, but it is a false illusion. Why? Until unless you are not getting the right answers in the numericals, we can't say that you have fully understood the concept. Are you getting my point? You need to understand. In order to get correct answer, we have to be conceptually good. Okay, once you are conceptually good, all the concepts, foundation, basic principles you have understood, then you will get the correct answers. So while solving question only, you will understand more of the details of the topic. You will more understand the concepts. More and more numericals you are solving, more and more clarity you will be having regarding the concepts. So don't think like, okay, just by reading the concepts only you will have all the confidence. Confidence will never come just by reading the theory part. confidence will be coming while solving the questions and getting the right answers. So that's why it is always advised, after understanding the concept, please try to solve at least PYQ questions, and for practice questions also you should do some tests, you should give, so that you can understand whether I am able to get whole understanding of that topic and subject or not. Who will decide? Okay, who will decide? Basically it will be decided whether you are able to solve the numerical or questions related from that topic or not. Okay, got it. So finally the answer for this one is 3151. Okay, damping coefficient answer is 3151 approximately Newton per meter. 3151 is the answer for damping coefficient. Okay, this damping coefficient 3151.6 it is. So well, as it is a damping coefficient, so we will write it Newton divided by meter per second, but we will write it like this, Newton second per meter. So this is the answer, 3151.6. Done. I hope this much is clear, everyone. Right? Okay, we'll move to the next problem. Next problem will be again from the vibration part. Yes, and this one is also a very important problem. It was usually asked in the this engineering services examination. Okay, so what they are asking here, please understand here. Disc of a torsional pendulum has a moment of inertia 600 kg centimeter square. Focus on the units. And is immersed in a viscous fluid. Okay, the brass shaft attached to it is of 10 centimeter dia. So dia is 10 centimeter, length 40 centimeter long. Pendulum is vibrating. The observed amplitudes on the same side of the rest position for successive cycles is 9. So this is 9 degree actually. This is 9 degree, not 99. This is 9 degree, 6 degree, 4 degree. Find the natural frequency and critical damping coefficient, and this G value they have given. Okay, so everyone please take 2-3 minutes and try to solve it. Within 2-3 minutes you need to solve this question. Do it everyone fast. But remember the unit they have given kg centimeter square. Standard unit is what? Kg meter square. So you have to change the unit as well. Right? We have to change the unit. Diameter is given, length is given, everything is given. So some of the basic things I will tell you here. See, in order to calculate first of all the natural frequency in this torsional pendulum case, it will be torsional stiffness Kt, as it is a case of torsion. So torsional stiffness Kt divided by this mass moment of inertia I. Now how to calculate this torsional stiffness? The formula will be Gj by L. This thing you should remember. Okay, and ideally it is equals to torque divided by theta. Stiffness is what? Load divided by deflection. In the case of torsion, load is what? Torque that we are applying to the shaft. Theta is what? The deflection we are having. Right? So T divided by theta. So torsional stiffness formula will be T theta by T divided by theta. If both the values are given, that's fine. If it is not given, we can calculate using Gj by L. From where we got this thing? From the torsion equation. From where we got this equation? From the torsion equation that you have already studied in strength of material. Right. So torsional stiffness you will get it from this one, and directly I value is given. Just change the unit and put it here. You will directly get the natural frequency. Directly you will be getting the answer of natural frequency here. Okay. So please do the calculation here everyone and tell me the answer of natural frequency. Do it fast everyone. Do it fast. So first is the natural frequency that they are asking, and then critical damping coefficient. So how to write critical damping coefficient also in the case of torsion? Okay, torsion case we will discuss here. Okay, torsional vibrations are there. In that case, how I will be writing the critical damping coefficient? You will understand that thing. But before that, solve this omega n. I've told you all the things. Torsional stiffness, all the values are given here. G value 4.4 into 10 to the power 10. What is J? Polar modulus pi by 32 into d to the power 4. D to the power 4. So D, dia is 10 centimeter, 0.1, okay, to the power 4. G into J divided by length L. L is 40 centimeter, that is 0.4. Right, so from here you will get the torsional stiffness answer. Okay, first you have to calculate this torsional stiffness. We will be using here and then we will calculate it. Okay, you have to be quick in the calculation part, guys. Please solve this question. Just I will mention here itself, like this value is for J. Sorry. Right, polar modulus J value pi by 32 into d to the power 4. Done. Tell me your answer for omega n. Your answer for omega n, everyone. So torsional vibration case is very important. I'm telling you this point. Okay. Torsional vibration case. There are three types of vibration: longitudinal vibration, transverse vibration, and then finally torsional vibration. This torsional vibration case is very, very important compared to other two cases. Okay. So we need to remember this formula, very important formula of torsional stiffness. This torsional stiffness formula is very, very important here. Okay, otherwise you will not be able to calculate omega n. Right, without knowing the torsional stiffness formula, you will not be able to calculate omega n. Right, so do the calculation first. Okay, finally see, answer that we are getting here for omega n is 4242.48. Yes, absolute, Rahul, absolutely correct answer. Sorry for the inconvenience, actually I got cold, that's why I'm having continuously sneezing here. So omega n answer, yes Rahul, superb, your answer is correct, 4242.48 radian per second. Now critical damping coefficient, next. We'll write it in the next page here. Critical damping coefficient. Now if you remember, in generally in the linear cases, how we are writing? This is the formula for linear translation case. See, sometimes redundant data will be given. So one more question that we can add here is calculate the logarithmic decrement. One more question I can add here, calculate the logarithmic decrement, right? So sometimes redundant data is given. You have to understand, we have to calculate the unknown. That is what they are asking. for that which given parameter is what useful. Okay, like that we need to understand. Critical damping coefficient like this, but in case of torsional vibration, how we will write? 2 into, instead of K we will write torsional stiffness KT, and instead of mass, the mass moment of inertia value will be coming, right? So calculate this as well, critical damping coefficient. For torsional vibration, do it everyone fast. Rahul, calculate the critical damping coefficient as well. Instead of stiffness, torsional stiffness we will have, and then mass moment of inertia instead of keeping the mass m value. Because in rotation, mass is not important. How the mass is distributed, that is what important. So distributed, how the mass is distributed, it is calculated by using a parameter called mass moment of inertia. Clear? Okay. So just put all those values here that previously we have calculated the torsional stiffness, that KT value we have to put it here, okay, into I, that is mass moment of inertia. Okay, you need to put it here and you will get the answer. Tell me your answers. $509, yes, 509, correct, Rahul, yes, absolutely correct. 509.09 actually, if you see, exact answer is 509.09. This is the correct answer. Critical damping coefficient answer is 509.09. Okay. So unit you will see here like this, Newton meter second divided by radian, because in the denominator radian per second it will come. Okay, done. Got it? Okay. Now next everyone, next problem, again from the vibration. That's why I've intentionally taken more problems from the vibration chapter. What you're asking, how to convert in SI. Okay, so you're asking about the mass moment of inertia basically. See, mass moment of inertia unit, standard unit is what? kg meter square only. Because if you see the formula here for mass moment of inertia, it is nothing but mr square. So for mass, the unit is kg, and for r, meter only, so meter square we will be having. Similarly for area moment of inertia as well, if you see I, okay, what is the formula here? We are having as area into the, let's suppose we are writing k, radius of gyration k square. So area means m square, k means m square. M to the power 4 is the unit of area moment of inertia. That is SI unit only. So kg centimeter square, okay. Kg centimeter square it is there. So you need to convert your centimeter into meter. You got it? Okay, great. So you need to convert centimeter into meter only. Okay, now see next this problem. Next problem everyone, again from the vibration. Okay, again question is from the vibration topic. Now read the question very carefully here. 350 Newton, that is what the weight. electronic instrument is attached to a ship deck which vibrates at an amplitude of 1.6 mm at 50 hertz. Now understand very important point. Amplitude they have mentioned and frequency of vibration also they have mentioned. This instrument is what? On the ship deck. It is attached to the ship deck which is what? Vibrating, and for that vibration amplitude and frequency also given. Instrument is to be isolated from the deck with 4 flexible mounts. Okay. Determine the required combined spring constant. They are asking the required combined spring constant of the mount such that, now the condition they have mentioned, amplitude of vibration of the instrument is no more than 0.3 mm. Now see, previously what was the amplitude? 1.6. Now with that attachment that we are using here, amplitude of vibration should not be more than 1.13. Initially 1.6, but as I've used this 4 mounts here, so my vibration, amplitude of vibration should ideally decrease. How much it should decrease? They have mentioned 0.13. Initially 1.6 was there. Now, and after that, using this mounts, some isolation will happen, and because of that amplitude will reduce to 0.13. So that's what the question they are asking. Okay. Determine the required combined spring constant. Spring constant is nothing but the spring stiffness only. Okay. Do it everyone fast. Okay, calculate everyone first. The weight they have given now 350 Newton. If I have to calculate the mass, so this 350 divided by 9.81, I will get the mass in kg basically. Okay, next. 1.6 mm was the amplitude of vibration. That is what your static vibration, because no damping is used. Static vibration 1.6 they have mentioned. Okay, at 50 hertz they have mentioned. Now the instrument is to be isolated from the deck with 4 flexible mounts, and now the instrument is should not having more than 0.13. So now amplitude of vibration they have mentioned 0.13 mm. This is the information given. Is in the question anywhere they have mentioned about the damping? Just read the question again, everyone. Just read it again and tell me any of the line is telling about the damping. Whether they have mentioned anything about the damping? No. So damping is not mentioned. Damping factor 0. So your formula will be like this. One minus r square. Now when it is under root is removed, plus minus sign will always come. Plus minus sign will be coming here. Correct? Yes or no? Simple thing. X by x static will be plus minus 1 upon 1 minus r square. Now all the values are given here. Okay, all the values are given here. We have to next solve it. Okay. Mass calculation, x static, x value 0.13. Now we have to keep it. Damping factor is 0. Okay. Now you have to calculate the answer here. Required combined spring constant. How you will be getting? For that, what is required? See, omega n equals to under root k equivalent divided by mass m. This is what we need here, and from here k equivalent stiffness I will be able to calculate. Got it? Now just solve everyone and tell me your answer. Okay, so if I put here 0.13 and 1.6 here, plus minus 1 minus r square. Now just simplify this equation here. Okay, we'll write it separately. 1 minus r square plus minus sign equals to, okay, 1.6 divided by 0.13. Let me check. 0.13, yes, correct. So just if you divide this value, what answer you will be getting? Let me write it here directly. 12.30769. 12.30769. This is the value. Now whether I should use positive or negative sign here, which sign I need to use here? If I use positive one, please understand everyone this thing. If I use positive one, what happens? R will go to that side and 1 minus 12.3, which becomes negative. So negative will not be able to solve. Right? Negative we are not able to solve here. Correct? Right? Ramesh, okay, I wanted to thank you for the fluid mechanics lecture. Thank you so much, Ramesh. Okay, you have understood the fluid mechanics concept. Okay, thank you so much, and keep practicing all the subjects, right? Gate booster that we are taking for all the subjects. So please attend all the gate booster sessions so that your practice and your confidence both will increase basically, and definitely it will help you in your gate examination preparation, and your gate score will definitely going to be what? Increase. Once you are attending this gate booster sessions, you will have a collection of important questions, quality problems you will be having, and once you are solving all those questions, you will get the confidence, right? And by the way, thank you so much for your fluid mechanics, your lovely comments. Thank you so much. Okay, now tell me here, we have to put positive or negative here? We have to use negative, because once I will use negative here, it becomes minus 1 plus r square. Okay, so your r square value equals to 13.30769, and from here r you will get the answer. Got it? So r is what? Omega by omega n. R value, your r value is actually equals to omega by omega n. Omega by omega n can be written as the ratio of f by fn. Same thing. There will not be any change. Omega by omega n, f by fn, like this it will be there. Yes or no? Are you getting the point? R equals to omega by omega n equals to f by fn. F frequency they have given. We can calculate here fn value. Fn value we can calculate from here, right? Because they have provided what? F frequency in the question. If you see, frequency 50 hertz they have provided. So whatever R value you will be getting, from that Fn you will get, and from Fn omega n you will be getting as 2 pi f. And from this value you will get omega n, and then finally omega n value I will put it here. Finally omega n value I will be putting here to get the answer. Yes or no? Is it clear now? So simply first calculate R. From that R value calculate Fn, because f by Fn equals to R. F value is 50, which is given in the question. Fn value will be getting. That Fn value I will use here in omega n. Then omega n value here to get this K equivalent stiffness. Got it? Do it fast, everyone. Yes, Rahul, what is the answer? 265705. Okay. Okay. The answer for omega n you're telling. See, I'm having the answer with me. Just let me tell you the answer that I'm having here for omega n. Because Fn value that I have solved here, Fn value is 13.706. That is what we are getting. And before that, what is the value of R? I will tell you. R value we are getting 3.648. This is the value of R. Okay. So R value you have to utilize here, because F value already given 50 hertz. Fn value will be getting like this. Omega n is approximately 86.119 radian per second, like this. 86.119. Now once you have calculated here omega n, now next thing is what we need to calculate? Stiffness. So omega n equals to under root K equivalent divided by mass m. So K equivalent, if I take the squaring, okay, if I do the squaring on both sides, it will be omega n square. K equivalent square will not be there. K equivalent, because already square root is there, na? Yes. So K equivalent will be omega n square multiplied by m. Omega n square is 86.119 square multiplied by the mass. Mass value, okay, if you see previously we have written 350 divided by 9.81. So that we need to do. So if you do it, the mass value you will have around 35 actually. That is 35.678. Okay, 35.678. And from here K equivalent stiffness you will be getting. So okay, the answer that you will have 264.6 kilonewton per meter. 264.6. So just cross check your answer. It is within the range. If you see, you will have 265.7 kilonewton per meter. Your answer is 265.75, but actual answer is 264. So it is near to the actual answer. So we can say it is under the range actually. But exact answer is 264.6 kilonewton per meter. And your answer is 265.7. Done. So I hope like how to use multiple relation to get the answer. This is very important here. How we can use different relation to get the answer. This is very, very important. So I think 3 to 4 numericals we have discussed from the vibration, entirely new vibration problems we have discussed. Now tell me, is there any confusion or any challenge you are facing in the vibration chapter of theory of machine? Any doubts you are having from the theory of machine vibration chapter? Is there any doubts? Okay, any concept regarding this vibration chapter, if you want to ask, you can ask right now also. We will discuss it here, so that again you will have more understanding of the concept. Clear? Okay. Okay, Rahul. It's clear to you. So now moving to the next problem here. Next, gyroscope problem. Very, very important. And here gyroscope case we are discussing for the ship. For the ship we are discussing this gyroscope problem. And this is an MSQ problem, guys. This is a multiple select question. This is a MSQ question. Okay, everyone, just try this MSQ problem. Torque method, yes, Rahul. Okay, I will again tell you regarding the torque method, how to use torque method. One more numerical I will discuss with you, and from that you can easily understand. Now for this moment, calculate this question. Calculate the answer for this particular question. Gyroscope in the case of ships. Do it everyone fast. MSQ problem from the gyroscope chapter, and the topic is the ship case. Okay, gyroscope is a very easy topic, I will tell you. Easily you will get full out of full from this gyroscope. If deflect theta about hinge, then moment of inertia calculation. Okay, okay Rahul, we'll discuss that also. Okay, in the end we'll discuss all of your doubts regarding torque method and regarding the calculation of moment of inertia as well. We'll discuss that thing. Okay, no problem at all. We'll discuss after, once we have completed all the questions, then we'll discuss all these things. Okay, I was telling you, like, regarding this gyroscope chapter, you can easily score full out of full, very easily. Just you need to be like very careful regarding the directions, because in this problem calculation is not involved that much. Main thing is what the directions, how to consider the directions. Okay, because if we have done mistake in taking the direction, we'll get wrong answers. That's why gyroscope easy also, but at the same point of time we have to be very, very careful. Got it? Okay, just try everyone and tell me what answer you are getting. Everyone should try. Three, 7, 6, 9 you are getting as an answer for this gyroscopic couple. Yes, correct. Correct, Rahul. Absolutely correct. That answer is correct. Gyroscopic couple formula is I, that is mass moment of inertia, omega s multiplied by omega p. That is gyroscopic couple. Okay, now see, mass moment of inertia, turbine rotor of ship having a mass 200 kg rotates at 2000 rpm and radius of gyration is given. Now whenever radius of gyration is given, how you will calculate mass moment of inertia? M mass multiplied by radius of gyration, mk square. Okay, so mass they have given as 200 kg multiplied by radius of gyration 0.3 square. From here you will get the answer. Now RPM is given, so angular velocity of spin will be 2 pi n. N is at 2000 rpm divided by 60. Radian per second. What about the precision velocity? See, the ship pitches with a bow rising at an angular velocity of 1 radian per second. Okay, directly omega p they have given. 1 radian per second. So all the values are given. Okay, easily you will get the gyroscopic couple. Now tell me, Rahul, your answer is correct, but apart from that, which option is correct? Because it is MSQ question, right? It is an MSQ problem. Your answer for gyroscopic couple is correct. Apart from that, which answer is there? Which one of the option is also correct? Gyroscopic couple value that you have calculated 3769. So approximately 3770. Okay. This is the answer, which is we can write approximately 3770. Apart from that, this answer, which other option is also correct? Tell me. Okay, just give me some time here. Actually, I'm continuously sneezing here, so maybe because of that you will get a disturbing sound here. Okay, so you are asking what is aft here. Okay, so first of all, basic geometry of the some basic terminologies in the ship you should know. Sorry. In the case of ships, some basic geometrical information you should know here. Okay, now see. Okay, first of all, this is longitudinal axis. This one is transverse axis. Okay, apart from that, see, this is the view that we are observing from the top. Okay, this is the view that we are observing from the top. Okay, remember this thing. Now, this side is known as port and this side is known as starboard. Now, as you see in the question also, they have mentioned if the ship pitches with the bow rising. Bow means the front part of the ship. Bow is what rising. This is what known as bow, the front part actually. And this is what known as aft, the rear side of the ship. Now, I hope this information is clear. All the basic terminologies are clear, everyone. Because this is the top view. From the top you are observing the ship. So these are the basic terminologies. Now, what happened actually here? See, one more diagram I will draw here so that you will have a better understanding. Okay, so now please understand here, these are the three different planes I am drawing here. Right, now see what happens here actually. So let's suppose this is the shaft we are having. Okay. This is our shaft, okay, for the ship. Now, as in the question they have told pitches with the bow rising. The front part of the ship pitches in the upward direction. Bow rising. Bow is the front part of the shaft. Now, when it is rises, what happens? See, it will rise like this. Now, we have to understand some basic thing. Because of this rotation, there will be what? Gyroscopic couple involved. And a reaction to that, there will be a reactive gyroscopic couple. Okay. So this is RGC. In short, I am writing RGC, and this is what? GC, gyroscopic couple. So your bow front part of the ship is basically rising, pitching in the upward direction. So bow rises like this. So for that, a couple will be there, gyroscopic couple, and opposite as a reaction to it, there will be reactive gyroscopic couple. Okay, now try to understand here. This is happening in which plane? Vertical plane. Because when bow rises, so this rotation is, okay, we are talking about which plane? Vertical plane. Now here right hand thumb rule is very, very important. Right hand thumb rule is very, very important. Now in the direction of arrow, we will keep our thumb. Okay, now why I am putting my right hand thumb in like this way? Because everything is happening in a vertical plane. This is a vertical plane. All the rotation is happening in vertical plane, right? So I will keep my thumb in the downward direction because arrow of RGC is in the downward direction. Then whatever the direction of fingers, okay, in which direction fingers are curled, try to understand in which direction fingers are curled. So if I see with respect to the terminologies of the ship, so from the top, if you observe how the ship will move towards like this. So when ship moves towards like this, it is basically steering towards the starboard. It is steering towards the starboard. Try to understand this again, very important. So pitches, the bow pitches in the upward direction like this. Okay, correct. So for that, some gyroscopic couple involved. Reaction to that, reactive gyroscopic couple. In the downward direction, reactive gyroscopic couple. Now fingers are curled like this. So it means ship will try to steer towards right direction, which is starboard. So that is what the effect of reactive gyroscopic couple. Now if you see the options here, so bow rising moves the ship towards the starboard. Yes, Rahul, you have mentioned B. Yes, absolutely correct answer. So B answer is correct, and gyroscopic couple value also they have mentioned correct. Okay. Basically, we'll be writing ship steers towards the starboard. Towards the starboard side. Ship steers towards the starboard side. Clear? So that's how we are able to understand, okay, the effect of reactive gyroscopic couple on the ship as well as on the plane. In all the cases of gyroscopic couple, use of right hand thumb rule is very, very important, right? See, pitching, rolling, it's very easy. In the fluid mechanics also we have discussed this thing. Pitching, I will tell you what is pitching here. Okay, here itself I will tell. See, if I talk about the rotation about the longitudinal axis, consider this part as your ship. If it is rolling, okay, if it is having a angular rotation about a longitudinal axis, wherever rotation is happening, you need to understand about which axis rotation is happening. Main point is rotation is there, okay, fine, but about which axis? Now, if the ship rotates like this, axis of rotation involved is longitudinal axis. So that type of rotation will be known as rolling. But if ship moves like this, in the vertical plane, if it moves like this, up and down like this, so the axis involved here for the rotation is perpendicular like this, transverse axis. Transverse axis is involved, yes or no? For this pitching case, okay, the ship will be moving in a vertical plane. So the axis involved here is transverse axis. So pitching. Now second thing is what? Steering. So ship will be steering towards either left or right. The rotation motion either towards left or right, that is what steering we are having. Is it clear? Other than that, we have this sway and this yawing. All these are not that much important here. Okay, it is not important, not at all important for GATE examination. That's why you should not go for this. At this point of time, you should not go for those things. At least you should know pitching. At least you should know rolling. At least you should know the steering. Only these three things you should know. Apart from that, whatever the things, motions we are having, that is not at all important for the GATE examination. Right? So this point you should remember. Okay. Otherwise, see, there are a lot of informations, but point is we have to stick to that syllabus which is relevant for our GATE examination. Pitching very important. Okay. Rolling is also important, and the steering part. Now, one question for you. What is the gyroscopic couple value for the rolling case? Tell me. What is the gyroscopic couple value for the rolling case? Tell me, Rahul, what will be the answer? Gyroscopic couple value for the rolling case. Ship और aeroplane का same लेना है direction. Direction like which direction you are asking, Rahul? Which direction you are asking? You are asking about the aeroplane. Okay. Same thing. Whatever analysis we have done for ship, same we have to do for aeroplane also. Okay. For example, I will explain you aeroplane case also. Let's suppose this is the shaft we are having for the aeroplane, and it is mentioned, it is rotating. Okay, see how to draw the rotation vector, it depends what kind of rotation they have given. So let's suppose this is the rear, this is the front side, front better to right nose, this is what? Tail. Okay, tail part of aeroplane. This is the shaft we are having. Yes, a longitudinal is same, Rahul, correct. Okay, I got it. So you're asking about a longitudinal. So longitudinal, I will mention like this. Along the length of the member, the axis is known as longitudinal axis. Simple. Now, in the case of aeroplane, nose and tail usually we call it. The point is we need to understand how to draw rotation vector. So, let's suppose this is what the rotation vector we are having. Right hand thumb rule. Okay, right turn or left turn? Yes. Okay. Okay, I got it, your point. So you are telling, sir, aeroplane takes the right turn, left turn. That is what steering. But what I am saying here, how to identify the rotation vector here? For rotation vector, we have to use right hand thumb rule. So in the direction of arrow, you have to keep your thumb. Fingers will tell how the rotation is there. So from that front side, that is from the nose side, it is rotating in which direction? Anti-clockwise. From the front side or the right side, the shaft is rotating anti-clockwise. That's why the rotation vector is pointing towards right. So if you see the fingers from the rear end, it is clockwise, but from the right side, it is anti-clockwise. Now, in the question generally they will tell aeroplane takes the left turn or right turn. Okay. So let's suppose if it takes the right turn, left turn, let's suppose. So it will be turned like this. So for that gyroscopic couple, as a result, reactive gyroscopic couple RGC. Now remember, when it is taking right or left, all the rotation is happening in a horizontal plane. It is happening in a horizontal plane. Understand this point. Plane takes the left turn. So that left or right is happening in a horizontal plane. Okay. RGC is pointing towards like this. Now it is not vertically downward. Actually it is in a horizontal plane. Because all this steering right and left is happening in a horizontal plane. So this RGC, how I will put it? Like this. So thumb away from the board, basically. This is the horizontal plane. Thumb will be like this. Outward, in the outward direction. And the fingers, how the fingers are curled, it will tell the couple acting on the shaft. So when this couple is acting on the shaft, tail part goes down and the nose part will lift up. because of the direction of the couple. This direction is what? The direction of the couple. Arrow, this thumb will tell. Okay, this thumb will tell the arrow. According to the direction of arrow, I will keep my thumb. Then this curl, how the fingers are curled, that we need to understand. Because of that, what happens? The tail part goes down, nose part goes up. And it is from the front, if you observe, this is anti-clockwise sense of couple. When anti-clockwise sense of couple is acting, tail part has to go down and the nose part goes up. Then only you will have this kind of thing, anti-clockwise couple. Then only you will have anti-clockwise couple. Got it? Okay. Now, next problem, guys. Yes, this is from our balancing chapter. This question is from the balancing chapter. Yes, Rahul, correct. Nose up, tail goes down. Correct. Your answer is correct. Single cylinder oil engine has a stroke, okay, 38, they have mentioned, and the crank makes 360 RPM. Okay. Crank makes 360 RPM. Okay, this is given. Reciprocating parts has a weight of 670 Newton. Revolving part has equivalent to 800 Newton. So sometimes they will give in terms of mg, sometimes in terms of weight. Revolving balance mass weight is introduced at a radius of 15 centimeter. Okay, balancing weight that we have introduced, it is also mentioned at what radius they are keeping it. So 15 centimeter they have mentioned. To balance the whole of revolving, so what we are balancing? Complete revolving mass and one half of the reciprocating mass. One half of the reciprocating parts we are balancing, but complete revolving parts we are balancing. Complete revolving, half of reciprocating. That's what our agenda here in this particular problem, to balance. So the question is the magnitude of the balancing weight required and the residual unbalanced force on the crankshaft. That is what they are asking. Okay, Rahul, just try this question. Stroke is 38 centimeter. Centimeter they have measured from here. Okay, stroke length, and one relation you should always remember: stroke length is twice of crank radius. Right? This relation you should always remember. So stroke they have given us 38 centimeter. RPM they have given 360. Okay, like that they have given. Reciprocating parts having weight 670 and revolving is around 800 newtons. Okay, so every detail they have mentioned. Now just everyone solve it. Okay, everyone, just try this question. So this statement is very important here. The whole of revolving mass and one half of the reciprocating parts are to be what? Balanced. So basically what equation we can write here? Whatever the balancing mass we are keeping here, okay, at whatever radial location, it will balance completely the rotating masses plus half of the revolving mass, half of the reciprocating. Okay, reciprocating. So we will just write it here so that it will be easy for you to understand. and here it is revolving mass, like this. So basically the question is magnitude of the balancing weight required. So MB mass, we don't know about this one. First of all, RB location we know. What is the location? 15 centimeter, 0.15. Revolving mass is what they have given, 800 Newton they have given weight. So 800 divided by 9.81 into crank radius, half of 38. Half of 38 is 19.19. Okay, plus half mass of reciprocating, 670 divided by 9.81. Multiplied by R, that is 0.19. So from here the balancing mass required directly you will be able to calculate. Just do the calculation and tell me your answer of balancing mass. What is the answer of balancing mass required? Do the calculation fast, everyone. Very basic thing. Balancing mass required. Okay. In this question they have mentioned half of reciprocating, so we have kept 1 by 2. If they have asked 1 by 3, 2 by 3, whatever fraction they have given, we will write it there itself in the equation. What will be the answer for this balancing mass required? Yes, Rahul, tell me your answer for this balancing mass. This is simple equation. No? Every value I have written this equation. In this equation I have written all the values. So MB value you should be getting very easily. Such a high magnitude of mass, just check the calculation, that much value is not possible. It is 146.5. 146. kg. This is what the balancing mass required here. Got it? Now, the residual unbalanced force on the crankshaft, how we can calculate here? See, if I draw the single slider crank mechanism here, okay, just to explain you the things. This is the slider we are having. Okay, see, this is the single slider crank mechanism we are having, right? Now, very important point here we need to understand. Okay, there are the two components here. Here two components we will be having. One along the line of stroke, and another one is perpendicular to the line of stroke. mr omega square cos theta, and this is mr omega square sin theta. Okay, whatever angle theta we have, okay, whatever angle theta we are having here, right? Now, what about this one? The unbalanced force, mr omega square cos theta. Okay, this is what the revolving reciprocating mass here. Reciprocating mass, mr omega square cos theta, because revolving is completely balanced. Revolving one is completely balanced. Okay, so mr omega square cos theta, reciprocating mass we have to keep here. Now this is what the balancing mass we have kept as per the information given now. So from that we have kept this much balancing mass. But the point you should understand always, okay, let me write it here, balancing mass, like this. Now the net values, okay, how I will calculate? Summation of forces along line of stroke you have to calculate, and summation of forces perpendicular to line of stroke. That's why you need to calculate like this: summation of forces along the line of stroke divide and summation of forces perpendicular to the line of stroke. Resultant answer, resultant magnitude of the residual forces will be calculated like this. Along LOS, line of stroke. Perpendicular. Like this. So now you can easily calculate, everyone. Done. I hope the approach is clear, everyone. Yes or no? Is the approach is clear? So net unbalanced forces along the line of stroke and net unbalanced force perpendicular to the line of stroke. Once you have calculated both the values individually, then you have to put it here in this equation to get the final answer of resultant value of the residual force, okay, which is unbalanced force present here in the system. Okay, that is what acting on the crankshaft only. Right, very basic question. Now I hope you will be able to do it from here. So I will keep it as a homework. You can mention your answer in the comment box also, right? Okay, and also guys, please join the Telegram group. I will be giving you the PDF of last theory of machine first session and this second session as well. Both the PDF I will be uploading in the IMS Gate Academy Telegram group channel. So if you have not joined till now, please join the IMS Gate Academy Telegram channel, and the description you will find out the link as well. In the description of the video you will get the link, so directly join to get all the PDFs there. Now next, the question from the cam and follower. Usually the questions coming from cam and follower is very less. So only one important information I will tell you regarding cam and follower. What you need to do, simply remember the velocity and acceleration relations. Velocity and acceleration formulas you need to directly remember for the cases like uniform velocity, uniform acceleration case, SHM case, cycloidal case. Total 4 cases we are having now. So from all the 4 cases you need to know the velocity and acceleration formulas. So that much is sufficient in the cam and follower, right? So for this question, maximum acceleration of cam and follower undergoing simple harmonic motion. So what will be the formula? If anyone remembers, because in the class, in the live class and offline class also I have discussed this thing, and we have derived actually. We have derived all the formulas. For all 4 cases we have derived all the cases, all velocity and acceleration relations we have calculated also. Okay, for simple harmonic motion, which option will be correct? Option A, h by 2 pi omega divided by phi angle of ascent whole square. We'll get the answer of maximum acceleration. Right. So that's all for the numericals. Now, again, this Telegram channel you can join. The simple link is there, IMS Gate Academy, or the link directly you can click on the link as well. Now, the doubt that you are asking, okay, Rahul, the doubt regarding the torque method. Yes, answer A is correct here. For this one, answer A is correct. The doubt that you are asking regarding the torque method. Okay, please understand this thing. Let's suppose a simple case I am taking here. Which case I will take? Okay, this case. Stiffness K, mass M for the disc. Now, in order to solve this question with the eye center method, sir, calories का direction भी confusion है. Calories, which calories you are asking? I didn't get your doubt clear. Like what you are asking? किसका डायरेक्शन क्लियर नहीं है, किसमें कंफ्यूजन है? टेल मी द कंफ्यूजन पार्ट, इन विच टॉपिक यू आर फेसिंग द डिफिकल्टीज. Okay, now see, initially disc was placed like this. What I have provided? Angular disturbance. This theta disturbance I have provided. So it has rotated by angle theta. Opposite to that, inertia torque will be coming. I theta double dot. Okay. Now once it is rotated, there will be what? Elongation in the spring. There will be elongation in the spring. Now where, in which direction spring force will act? When there is a elongation, spring force will act in which direction? Towards left. Okay. This is what the deflection in the spring, and the spring force will be acting like this. Got it? Coriolis acceleration. Okay. You need to mention acceleration also, na? It's written the wrong spelling. Okay. Coriolis acceleration I will tell you. How to identify the direction as well. Don't worry. Spring force. Now spring force is acting like this. This is the mass. Okay. There will be a moment produced by the spring force in anti-clockwise sense. Spring force multiplied by the distance r. Okay, now see how we will solve it. Inertia torque I theta double dot plus this spring force moment multiplied by r equals to 0. Now mass moment of inertia you have to take about a point about which rotation is happening. This is the eye center for a disc. You told the mass moment of inertia. Okay. How to write the mass moment of inertia? For the disc about the center, it is mr square by 2. But let's suppose I have to calculate about this point A. So for this one, parallel axis theorem I will use. First, mass moment of inertia about the center point mr square by 2 plus mass of the body multiplied by the distance from center to the point of consideration, that is r square. Okay. So finally, the mass moment of inertia about point A equals to 3 mr square by 2. This will be there. Three mr square by 2. So directly value I will be putting 3 mr square by 2. Theta double dot. Spring force. The spring force will be what? K. Stiffness multiplied by deflection. This much deflection is there, x. Now how to write this x deflection? this is what r, and what theta we need to multiply, r theta, that is what the deflection. Again r is already there, 0. So theta double dot k r square divided by 3m r square by 2. So like this we will be having theta equals to 0. Now from here you will get the answer of omega n very easily. So you will be have 2k by 3m radian per second. Got it? Now Coriolis acceleration you are asking, right? Okay. Coriolis acceleration formula, I hope you remember, 2 into velocity of slider multiplied by rotational or angular velocity of the bar in which the slider is what? Rotating. A slider is what? Sliding, not rotating. See, this is the hinge point, this is a slotted bar we are having, and this is the slider. Now the slider is sliding on a link which is under rotation. Okay, got it? So let's suppose it is rotating like this, clockwise. Slotted bar is what? Rotating clockwise, slider is sliding in this direction, okay, outwards. Energy में half mv square. हाँ, v equals to r omega r theta. Oh, velocity equals to r omega, and the displacement that we have is x. So see what happens. No, this is initially it was like this. Now after that it has turned this angle theta. So what will be this distance? It will be written as r theta. Initially it was like this, but it has turned by this theta. How much linear displacement it will have? R theta. Energy method also you can use, but comparatively Newton's second law method or D'Alembert principle is far easy and less time consuming. Got it? Now see, the doubt there you are asking regarding Coriolis component of acceleration. First you have identified in which direction the slotted bar is rotating. Okay, that we have identified. The slider is what? Sliding in this direction. Okay, this is the v, velocity vector of slider, right? This arrow I've represented for the velocity vector of a slider. Now step number 1, first of all consider the rotation of slotted bar. Consider the sense of rotation. Consider the sense of rotation for slotted bar. Second point, rotate slider's velocity vector by 90 degree as per the rotation, as per the sense of rotation, as per the sense of rotation. Slotted bar. Now see, Rakesh, please, Rahul, sorry, please be careful, okay, while using these two steps. You have to be very careful here, right? First, sense of rotation, clockwise, okay. Then next what I need to do? I need to rotate the velocity vector of the slider. Important point, slider velocity vector. So outward they have mentioned, so velocity vector will be like this. I need to turn by 90 degree. 90 degree I can turn like this or like this. Now whether it will be like this or like this, who will decide? The rotation of the slotted bar. So rotation of slotted bar is clockwise. So it will be rotated by 90 degree in clockwise sense. So Coriolis acceleration will be like this. Is it clear, Rahul? Tell me first. Is it clear? Tell me, is it clear? Yes or no? Is it clear? Rahul, tell me, is it clear? Yes or no? Coriolis acceleration direction. Right, because only two steps are there, right? Step number one, sense of rotation we need to know, and after that, slider velocity vector I need to turn, right? Okay, great, superb. So that's all for theory of machines session number 2. Okay, we have completed most of the numericals from the vibration, one numerical from the gyroscope, and one from the balancing chapter, and one from the cams and follower, right? The PDF of this session and the yesterday's sessions, both the PDF will be available in the Telegram group. Again, I am telling, so please join the Telegram group. And for more informations regarding the webinars that we are conducting, regarding the latest recruitment notifications and the quizzes, everything you will be getting there. Okay, so that is one-stop solution for all GATE preparing students. So please join that Telegram group sessions as well. Okay. Thank you so much from my side, and all the best for your GATE 24 examination. Keep doing hard work, keep attempting the mock test, and on the daily basis, please improve yourself, okay, in the GATE preparation journey. Thank you so much and all the best. Bye-bye. Omega का direction का perpendicular. Yes. Correct, Rahul. Your point is correct. Perpendicular to, see, this is velocity vector, 90 degree I need to turn. Only option is either I can turn like this or like this. Who will decide it will rotate like this or like this? Omega. Omega is clockwise, so I will turn 90 clockwise. Otherwise, anti-clockwise I will rotate. Yes, Rahul, tell me. What's your doubt? Tell me. Okay, Rahul, please mention your doubt. Rahul, what's your doubt? Velocity of sliding in gear. Omega 1 plus omega 2. So, okay. Velocity of sliding in the gears. You have to take the distance. Okay, you have to take the distance. Distance from your point of consideration. See, it depends what they have asked. Velocity of sliding they have asked, no? So, for that they will tell during the approach side or during the recess side. They have to tell, then only we will be putting that value. Because path of approach, we have to write it as per the information given, or the path of recess as per the information given in the question. It's not like sometimes we will be writing for approach, path of approach distance, and sometimes path of recess. It's not like that. For maximum, whichever is the maximum distance. Okay, if you want to calculate maximum sliding velocity, we need to keep the distance maximum. Distance will be measured from the point of contact to pitch point. From point of actual point of contact to pitch point distance, that distance matters. Got it? But in the gate chapter, Rahul, understand, gate train has the highest possibility, highest probability basically, that question is coming from epicyclic gate train problem. Generally, gates related problems are very less. Okay. This kind of path of approach, path of recess, you can see the gate previous year questions. You will never see any question of path of approach, path of recess. This type of questions they are not asking. So gate train problems are far more important compared to this one. Okay, I hope you got the answer. Correct? Okay, Rahul, then thank you so much. Bye bye, and all the best for your Gate 24 examination. Thank you.